Greetings, everybody. This is the second set of notes in the plate tectonics unit. It's called ES 7.2 Plate Boundaries Notes. And as always, your task for this assignment is to write down everything that's in orange text, either handwritten or typed. You can pause the video if you need more time. So this photograph is of Mount Everest in the Himalayan mountains. Mount Everest is the highest peak above sea level. Lots of people climb it every year, and it's pretty high. The reason why the Himalayan mountains are there in the first place, though, is because the Indian subcontinent smashed into the Eurasian continent about 50 million years ago. And that convergence of the two land masses pushed up the crust to create the Himalayan mountains. Tectonic plate motion. So, as we talked about before, Earth's lithosphere is the crust combined with the upper rigid part of the mantle. Lithosphere can be broken down into the prefix litho, which means rock, and then sphere means globe. The lithosphere is divided into tectonic plates. These plates are moving because they are floating on top of the asthenosphere, which is the flowing part of the mantle. The plates move because of convection below them. Remember, convection is warm material rising and cooler material sinking. Convection is the driving force behind the plate motion. And convection happens anytime you have fluids of different temperatures or different densities. On a pot on your stove that's boiling, the warmest water is rising from the bottom and relatively cooler water is sinking, creating this circular motion that also happens inside the Earth's mantle. It's called a convection current, and we also have them in the atmosphere and in the ocean, with warmer fluids rising and cooler fluids sinking. Now, the rocks in the mantle aren't exactly a fluid, they're kind of plasticky, but they have movement to them. As the plates move, there is friction between them. This causes geologic activity at plate boundaries, such as volcanoes, earthquakes, mountain building, etc. So here's a map of different plate boundaries, and there's 3 different types of plate boundaries, and we're going to talk about those and come back to this map again. But anywhere where there's 2 different tectonic plates touching, it's called a plate boundary. A plate boundary is an area where 2 tectonic plates meet. There's 3 types: divergent, convergent, and transform. Divergent plate boundary here with 2 plates moving away from each other. And on this map, everywhere where there's a light blue line is a divergent plate boundary. Notice that there's areas in the ocean where there are divergent plate boundaries. Those are called mid-ocean ridges, and that's where new oceanic crust is created. A convergent boundary has 2 plates coming together. And you can see on this map where the convergent plate boundaries are. Those are the dark blue lines. And the other type is a transform boundary with a side-to-side motion. Those are the purple lines on this map. Each plate boundary type is associated with a particular type of stress. Divergent boundaries have tension, that's pulling apart. Convergent boundaries have compression, that's smushing together. And then transform boundaries have shearing, which is a side-to-side motion. So tension at a divergent boundary, it's like a tug-of-war pulling in 2 different directions. Compression is pushing together. That's a convergent boundary with 2 plates smashing into each other. And then shearing is like a pair of shears. It's a side-to-side motion. They're moving past one another in opposite directions. Every plate boundary is associated with faults. Faults are smaller breaks or cracks in the rock. And they're usually kind of at an angle, like the one we see in this picture. A fault is a break or a crack in the rock. Faults are different from plate boundaries, but faults occur near plate boundaries. There are 3 types of faults. We have normal faults, reverse faults, and strike-slip faults. and each one corresponds to a type of plate boundary and a type of stress. On a normal fault, the rock is sliding downhill, the stress is tension, and they're found near divergent plate boundaries. On a reverse fault, the rock is pushed uphill, and their stress is compression, and these are found near convergent plate boundaries. We'll come back to this. And then strike slip fault has a side-to-side motion. The stress is shearing, and these are found near transform plate boundaries. See, moving past each other in opposite directions. Each boundary type is known for geologic processes. So divergent boundaries is where new crust is formed, and you have earthquakes, volcanoes, and rifting. I'm going to go back to this picture up here. This is the Great Rift Valley in Africa. It's at a divergent plate boundary. Often divergent plate boundaries are in underwater, but this one's on land, and it's creating a giant valley in Africa. And one day, the sea will fill this valley. Convergent boundaries is where crust is destroyed, and you have earthquakes, volcanoes, subduction, and mountain formation. We'll talk more about subduction later. And then transform boundaries are mostly just known for earthquakes. So that is the second set of notes on plate boundaries. This is everything that you should have, so if you missed something, you can pause it here and catch up what you missed.